Good afternoon or night or morning, whenever you guys are watching this. Today we're going to solve equations with rational numbers. Remember, we discovered a couple weeks ago, before the Thanksgiving break, that rational numbers are numbers that can be turned into fractions of any sort. So we have decimals, we have repeating decimals, we have whole numbers, integers, natural numbers. Okay, we're going to be dealing with lots of fractions and decimals in this chapter. So just be prepared, but they're not that bad. All right, we're going to do a couple of examples here. The first one is this example right here. We have negative 3640 equals n minus 1856. So notice I was reading this kind of like they were amounts of money. It's helpful to me to think of a scenario for each one of these problems. That way I have a good, easy way of predicting what my final answer is going to be. And since my final number, since my sum here, or my difference, is a negative number, I kind of tend to think of being in debt, right? Being owed money, or owing somebody else money. So maybe here in this original equation, I borrowed some lunch money from some people, a lot of lunch money. And then I decided that I needed some more money. I really needed some more, I don't know, maybe it was the day that the Twinkies went out of business. So I bought a lot of Twinkies, $18 worth of Twinkies. Here's a Twinkie. Okay, $18 worth of Twinkies. So I had some money, and then I spent $18.56 more, and now I am way more in debt. Look at this negative number. Not only do I not have any money, I am actually owing people money. So here is the problem. I need to figure out how much money I started with. Right here, that's the n. So in these problems, I want to get the n by itself. This is going back to, I think, chapter 2 in our textbook. We talked about solving problems that were one step. The way you do this is by reversing whatever sign is in front of your number that's with the variable. So here's my variable. I'm going to keep that one where it is. I'm going to take this term right here, this negative or minus 1856, and combine it over here with my other like terms. Remember, we talked about like terms a couple chapters ago. They're terms that have the same variable or no variable, or the same variable and exponents. These two have no variables, so we can combine them. The way we combine them is by doing the opposite of whatever sign is in front. If it's addition, you do subtraction. If it's subtraction, you do addition. If it's multiplication, you divide. And if it's division, you do multiplication. So just whatever it's telling you to do, you do the opposite. So here we have subtraction, so we need to add. We're going to add 1856 to both sides. It's like a seesaw. If you do it to one side but not the other, somebody's going to get injured. Okay, so I have negative 1856 and positive 1856. Those cancel out. Okay, so then I have to do it to this side too. I'm adding 1856 to negative 3640. Now this might seem a little complicated because we have a negative number and then we're adding something to it. Remember that if you have different signs, if you have unlike signs, you subtract. So I can take this 3640 and I could subtract 1856 from that. Oh, I thought I paused it. Sorry for the silence. If you subtract from that, all right, so 3640 minus 1856 gives us a grand total of 1784. Remember that when you are subtracting these two numbers that have opposite signs, this one's negative, this one's positive, when you're adding these two and they have different signs, you use the sign of the bigger number. 36 is bigger, so our answer is going to be negative because the 36 is negative. So our final answer here is negative 1784. $17.84. So before I bought all those Twinkies, I had a grand debt total of $17.84 that I owed my buddies. Then I borrowed $18.56 more, so now I owe my friends negative $36.40, which is not so good for me. Alright, here's our second example problem that we're going to do. Again, we want to get the variable by itself. That's the whole point of these algebra type equations. We want to get the variable alone. And in the last page, or the last example, I showed you guys that what we have to do is the opposite of whatever's happening. Between this $14.99 and this C, there's multiplication happening. This is the same thing as $14.99 times C. So the way that we get rid of this $14.99 is by dividing. This is multiplication. The opposite of multiplying is dividing. So I'm going to divide by $14.99. These are going to cancel out, and whatever I do to one side, I have to do to the other side. So I have C left on this side is equal to $59.96 divided by $14.99. Alright, here's the work, proof that I did it. I divided using long division and found that $14.99 goes into $59.96 exactly 4 times. So when I divide this out, I end up with C equals 4. A good example of this type of scenario is, let's say you're going to go buy CDs. That's why I put a C here instead of an X or another type of variable. Each CD is $14.99. I have $59.96. So I have $59.96 in my pocket. Basically, I want to know how many CDs can I buy that are $14.99. So the way to figure that out again is to get that variable by itself. $14.99 times the number of CDs I can buy will give me a total of this amount. So I can buy 4 CDs at this price of $14.99 before I max out my budget. Alright, here's our last example for the evening. We are going to do this problem here. 4.5 plus x equals 1 3/8. So I'm going to do the same thing I did in the last several problems. I want to get this x to be all by itself on the side of the equal sign. What I'm going to need to do is combine my other terms. This 4.5 and this 1 3/8 are like terms, so I'm going to combine them. I'm going to combine them by doing the opposite here. This 4.5 is positive, right? So if it's a positive number, in order to move it over here, okay, I need to subtract it. So if I subtract 4.5 from both sides, I'll be left with x all by itself. Now, this one's a little bit tricky because we have 2 fractions. We have 1 3/8 minus 4.5. So this is the problem we're going to be doing today. These are fractions. If you'll notice, they have uncommon denominators. We need to get common denominators. So we have 8, we have 2. The multiples for 2 are 2, 4, 6, 8. I know that 2 times 4 equals 8. So 4 is kind of going to be my magic number here. I'm going to change both of these into improper fractions so that I can do my subtraction a little bit easier. This first term here, 1 times 8 is 8, and 11. This is 11 eighths. And I'm going to be subtracting from that. 4 times 2 is 8, 9. This is 9. Oops, looks a little funny. This is 9 halves. Again, uncommon denominators. We have to fix that. And the way we're going to do that is by multiplying over here both of these by 4 so that we get 8 as our common denominator. So we are going to do 11 eighths minus 2 times 4 is 8. 4 times 9 is 36. Now all I have to do is subtract. We have positive 11 minus 36. That's the same thing as 36 minus 11. The bigger number here is negative, so my final answer is going to be negative. We have, that's the same thing as negative 25/8. So negative 25/8. If I want to convert that into a mixed number, it's going to be negative. I know that 8 goes into 25 a grand total of 3 times with 1 left over. So my final answer here is going to be negative 3 1/8. So the main thing for you guys to remember for today is those solving equations hints that we learned from earlier in the year. Solving equations. When you have an addition or a positive number, what you need to do to move it, or to basically you're getting the variable by itself. So remember that addition and subtraction are opposites, multiplication and division are opposites. So you can use these things that we know to get the variable. By itself. All right, so have a good night.